Okay, so we're going to take implicit differentiation of all of these equations. So 3.7, what is differentiation? So differentiation is just taking the derivative. That's all we're doing, guys. We're taking derivatives. So let me remind you about regular derivatives instead of this implicit, okay? So they're all derivatives, but when you take a derivative of y equals, it's pretty straightforward. You would get y prime equals 2x plus 3. So this y prime is our lazy way of writing dy over dx, right? So it's okay. We can totally write it like this. I always do. Even on the AP test, you can do that, okay? But we can assume, because it doesn't have anything else, we can assume that this derivative of y is in terms of x. So technically, it's derivative of y in terms of x. Okay, so a little more reminders. So if you take the derivative of any function in terms of x, you get that function prime, right? So this is like y prime. Derivative of y is y prime. Derivative of f is f prime. The derivative of g of 2x, is, remember this is the chain rule, so the derivative of g of 2x is g prime of 2x times the derivative of the inside, which is 2. So the derivative of f is f prime, the derivative of g is g prime, the derivative of x is 1, right? Because it's the derivative of x in terms of x, so it's just 1. So if it's in terms of x, then you can just take the derivative and then you take the you get a 1 instead. But if it's in terms of x and it's a g, then you have to write g prime. If it's in terms of x and it's an f, then you have to write f prime, right? So now we're going back to implicit differentiation. So let's say you have something like this. What is the problem with this? I know there's an answer, just ignore it. So what is the problem with this? How come we can't do it the other way? Well, the other way, you solved for y. You can't solve for y for this equation. There's a y squared and there's a y, so that's no good. So instead, implicit differentiation will always work, but we only do it when we have to, right? It'll always work, and this is what you do. You literally take the derivative just as it is. So this blue part represents a product. It's x squared times y. So the derivative of a product is going to be box times triangle prime plus triangle times box prime. So we'll see that in a second. And then plus, here's another product rule. Box times triangle prime plus triangle times box prime equals, and then the derivative of 6 is 0. Okay, so let's see how that works out. Here's my box. Here's my triangle prime. And then plus triangle, that's my y, times box prime, that's my 2x. So the derivative of this product is this product rule right here. And then the derivative of this product is this product rule right here. So let's see. Here's my box, x. The derivative of y squared is 2y to the first power times y prime. I never write a 1 as a power because the 1 kind of looks like a prime. So I just leave it, right? Y is to the first power already. Plus my triangle times the derivative of my box, which is 1. So that equals 0 because the derivative of 6 is 0. Okay, from there, I want to solve for dy over dx. I'm solving for y prime. So see how there's a y prime here and a y prime here? I want to solve for y prime. So what do? When I solve for something, I need to get everything else on the other side. So I'm going to take this, I'm going to take this, I'm going to subtract it to the other side. So there we go. Subtract that and that to the other side. And then now I have my y primes on the left side. I need to factor them out to the front. So factor them out to the front. And then I did another step over here. You don't have to, but you know that's going to match our answers. So I factored out the negative, right? So I factored out the y prime and I factored out the negative. And then what do to solve for y prime? You just divide. So you divide, you get your final answer. It looks just like that. Okay, so you're going to actually do number 2. The answer is right there. Do number 3. The answer is right there. You're going to do number 4 and 5. I'm going to post these questions, and you already know what the answers are. So I'm going to post these on the homework helpline, okay? Here is one more, number 6. I'm going to do number 6 with you, okay? So number 6, I'm going to do number 6 with you. So find the slope of the tangent line, okay, of that. So first we have to find the derivative of this, and then after we find the derivative of this, to find the slope of the tangent line, we need to plug in pi to whatever our derivative is, right? Pi, and then 1 is our x, or our y value, so xy. Okay, so let's start with taking the derivative. What is the derivative of sine? Cosine of x over y times the derivative of the box. So here's our first step. The derivative of sine is cosine times the derivative of x over y, which is low d high less high d low, denominator squared below, minus, is right here, there's a minus. The derivative of x cubed is just 3x squared, equals the derivative of 31, which is a constant, is 0. Okay, from there, I don't need to solve for y prime. Guys, I can just plug in before I solve for y prime. So here's what I mean. Everywhere you see an x, you put a pi. Everywhere you see a y, you put a 1. And then you get this, right? And then you start to work it out. What is the cosine of pi? You have to think about your unit circle. The cosine of pi is -1, and then you move that to the other side, because eventually you want to solve for y prime. So eventually solve for y prime. However you're going to do it is fine. So there's y prime. And then final answer, basically. Okay, so there are 2 examples. You're going to do 2, 3, 4, and 5, and then I'm going to ask somebody to post it, okay? I'm going to say for the first day, so for today all the way to tonight, I'm going to say if you have if you've only volunteered 0 times or 1 time, then go ahead and post these, okay? But if you volunteered more than 1 time, then we're going to wait until tomorrow to see if there's any to post, okay? Okay, on the back, there are some questions, and I want to take a look at the back. I want you to take a look at the back and see from here, what could your answers be? I want you to try it, okay? So this is a velocity graph, and I want you to see, what is v of 2? Well, this is v, so what's v of 2? V of 2 is 1. And then all of the answers are on the other side. And I don't want you to just copy them. I want you to try them, and then we'll talk about whatever we need to talk about tomorrow. Okay, so we'll talk about all these tomorrow. There are some that I crossed out because we can't do it yet, and there's other ones that we'll talk about. All right? Okay, good luck. I'll see you tomorrow.